In this lecture, we solve the same question which we have solved in the previous lecture, but we use a different method to solve the question. So the question is find the complex number z if mod of z plus I, which is equal to mod of z, and argument of z plus I upon z, which is equal to pi by 4. Then we have to find the value of z. We have mod of z plus I equal to mod of z. So we have to transpose this to left hand side and it will become mod of z plus I upon z, which is equal to 1, and argument of z plus I upon z equal to pi by 4. So now we have a one complex number z plus I upon z whose modulus is 1 and the same number's argument is pi by 4. So this can be written as, since we know what is the modulus and argument of any complex number, then we can represent that complex number into the form of polar form, which is nothing but z equal to r cos theta plus I sin theta. So here the value of r equal to 1 and the value of theta is equal to pi by 4. So z plus I upon z can be written as cos pi by 4 plus I sin pi by 4. Now our aim is to find out the value of z. So z plus I is equal to z times of cos pi by 4 plus I sin pi by 4. Again, z, now let us transpose this to this side because this is z and this is also the multiplication of z. So z we can take outside, so it is 1 minus cos pi by 4 minus I sin pi by 4, and this I goes to right hand side, which will become minus I. Now, so z is equal to what? Minus I upon, so we have again taken the minus sign common from both the part. I upon this 1 minus cos pi by 4 can be written as cos pi by 4 minus 1, and this minus I sin pi by 4 is plus I sin pi by 4. So this minus sign is, we have multiplied by minus sign on both the sides, which gives us z equal to I upon cos pi by 4 minus 1 plus I sin pi by 4. So we have to do the realization. We multiply the complex conjugate of cos pi by 4 minus 1 plus I sin pi by 4 in denominator as well as numerator. So now, since its conjugate is cos pi by 4 minus 1 minus I sin pi by 4, so we are multiplying the same number with numerator and denominator, which gives us, now let us try to multiply it. So z is equal to, we have to first multiply with I. So this I and minus I sin pi by 4 will become minus I square is plus I square is minus 1. So minus into minus plus 1. We have sin pi by 4 is the first term. Minus I cos pi by 4 minus 1. Cos pi by 4 minus 1. This should not be minus, it should be plus. Cos pi by 4 minus 1 whole divided by a plus b and a minus b. So cos pi by 4 minus 1 whole square and minus I square sin square pi by 4. So minus minus will become plus. So it is sin square pi by 4. So z is equal to sin pi by 4 plus I cos pi by 4 minus 1. And if we simplify it, what is that? Cos square pi by 4 plus 1 minus 2 cos pi by 4 plus sin square pi by 4. So cos square plus sin square pi by 4 will become 1. Then this 1 and then minus cos 2 pi by 4, which gives us 1 upon 2. This is 1 plus 1 is 2, and this is minus 2 cos pi by 4. So we can take 1 upon 2 outside, and this is sine pi by 4 upon 1 by 2, which is equal to sine in multiply by sine pi by 4 upon 1 minus cos pi by 4, and this is 1 minus cos pi by 4. So this will be this is plus sign, not minus sign. So this is 1 minus cos pi by 4. It is cos pi by 4 minus 1. So if we take minus sign outside, then we have minus I, because these two will be cancelled. We have only minus I. Now this sign is okay, minus sign. Now let us again simplify it. We know that sine 2 theta equal to 2 sine theta by 2 cos theta by 2. No, sorry, sine 2 theta is equal to 2 sine theta cos theta. So here this is sine 2 times of pi by 4 can be written as 2 times of pi by 8, which can be written as 2 sine pi by 8 into cos pi by 8. So this is written over here, and 1 minus cos pi by 4. So we know that 1 minus cos theta is nothing but 2 sine square theta by 2. So instead of theta, it is pi by 4. So it will become 2 sine square pi by 8 minus I. Now, if we divide these two terms, so 2 will cancel. Sine pi by 8, sine pi by 8, 1 will cancel. Cos pi by 8 upon sine pi by 8, which is nothing but cot pi by 8 minus I. So this is the desired complex number Z, which is given by 1 upon 2 whole times of cot pi by 8 minus I. So in this example, instead of using the Cartesian form of the complex number, we use the polar form. So this is the desired answer. Thank you.